I started the recording now. All right. So the first thing I was going to talk about today is fractions. So fractions are important, even though to an extent you can do them on the calculator. But if you know how to do them without the calculator, that really helps a lot. Sometimes there's going to be cases when you get into things like, you know, algebraic expressions and stuff where you won't be able to use the calculator. It won't help you. So it's really important to know how you know, fractions work and everything. So first, it's easier to talk about multiplying. That's one of the easier things that we can do with fractions. So with multiplying, you just multiply straight across the top and straight across the bottom. So are you guys seeing my notes here as your main screen on Zoom?
Mm-hmm.
Yeah, okay, good. Okay, all right, so so you also have to have your fractions reduced. So if they're able to be reduced, I always start with that, but otherwise just multiply straight across. So like 2 times 5 would be 10, and then 3 times 7 would be 21. So that your answer would just be 10 over 21 for that. On number 2 right here, you can reduce the 3 and the 9. So that's what I would do first, because 3 goes into 9 3 times. And then you can put a 1 here if you know, basically that's what it would be. And then 1 times 8 would be 8, and then 13 times 3 would be 39. So it would be 8 over 39. All right. And then whenever you have to divide fractions, it's basically the same thing, except for you have to flip the second fraction and multiply. So this would turn into 8 over 11 multiplied by 7 over 5. And then from there, you can just multiply straight across. So like 8 times 7 is 56, and then 11 times 5 is 55. All right, so you'll notice that in this case, our answer was an improper fraction. We have 56 over 55. And so we're not going to, we're just going to leave it like that. We don't want to change it to a mixed number because improper fractions are just easier to work with. So we're always just going to leave the answer like that. Mixed numbers is more like, you know, if you're doing a recipe, yeah, 1.5 versus instead of 3 halves makes more sense. But when we're just doing calculations, the improper fraction's easier to work with. So just leave it as an improper fraction and it's totally fine. All right. Does anybody have any questions or comments? Is this working, or you all are seeing what I'm writing and everything? It's good. Okay. Okay. Let me do. Okay, let me do a question on learning catalytics. I'm going to go ahead and give you one. All right. And I'll go ahead and write the question here on my notes for those of you who aren't able to see it for whatever reason. If you're not on learning catalytics, or if you're watching it back later, it's 2/3 multiplied by 1/4. So that's our question that we're doing on learning catalytics right now. All right. Okay, so in this case, it's multiplication, so we're just going to multiply straight across. However, I would reduce it. It doesn't really matter. You don't have to reduce it first, but I always just reduce it first because that seems like it would be easier. So like 2 goes into 4 2 times. And so then on the top, you just have 1. And then on the bottom, 3 times 2 is 6. So 1/6 is actually the correct response that we're looking for here. Okay. Now somebody said 2/12, which is, so yeah, if you didn't reduce it, you just did 2/12. Okay. But that's not reduced. So you always need to reduce your answer. So that's fine if you had 2/12, but you would just need to reduce it because like 2 goes into 2 1 time and then 2 goes into 12 6 times. So the correct response we're looking for is 1/6. Okay. Any questions? All right. Okay. All right. Let's do another one on learning catalytics. Oops. Okay. Yeah. All right. So the next one I have on learning catalytics has -2/3 times 3/5. So even if you're not on learning catalytics right now, you can just try to work that question on your own. Okay. All right. So in that case, pretty much you can just cancel those 3's out, and then it just ends up being -2/5. All right. All right. So I'll go ahead and work another example. Okay. So this one's dividing. So let's see. 12/27, and then that's going to be multiplied by 9/4. All right, now we can definitely cancel out a lot of stuff here. So I want to do that first. That's going to make it easier. All right, so let's see. I know that 4 could go into 12 3 times, and I know that 9 could go into 27 3 times. So, I mean, that essentially is 3/3, which is just 1. So the final answer there would be 1. All right. So if anybody has any questions at any time, just feel free to let me know. All right. Number 5, it says 6 times 3/2. So 6 is the same thing as like 6/1. So we could write it that way. Okay. All right. And then let's see. We can reduce because 2 goes into 6 4 times. So then basically it's just 4 times 3 is 12. And on the bottom, it's just like 1 times 1. So you could say it's 12/1, but we know that's basically just 12. Okay. All right. Let's see. Let's do another one on learning catalytics. There you go. So I've got negative 9/10 divided by 2/5 is the question we're working on for learning catalytics. So everybody go ahead and try to work that one out. And you know, it doesn't make any difference whether the negative sign is like in front of the whole fraction or if it's next to the numerator. Either way, that doesn't make any difference. It's the same thing, just in case you were wondering that. All right. Okay. So the first thing we should do is flip the second fraction and multiply. So that's going to make it negative 9/10 multiplied by 5/2. And then the next thing I would do is see if I can reduce anything. So let's see. I know that 5 would go into 10 2 times. So then on the numerator, I just have negative 9. And then on the denominator, I have 2 times 2, which is 4. So that's negative 9/4. So that's the correct answer right there. Okay. Now if you, let's see, yeah. All right. Any questions about that? Let's see. Let's do another one on learning catalytics. So this one is 9/10 divided by negative 5. Okay, so that's the question we're working on. Go ahead and work on that question. All right, let's see. So negative 5 is going to be the same thing as negative 5/1. And then you would flip that second fraction. So it would end up being 9/10 multiplied by negative 1/5. And again, it doesn't really matter where you put the negative sign. It's just a negative 1/5. Typically, we don't put the negative sign on the denominator, either out in front like this or put it with the numerator. All right, so then let's see. At that point, 9 times negative 1 is going to be negative 9. And then on the bottom, 10 times 5 would be 50. So negative 9/50, yeah, is the correct answer. So yeah, don't put the negative sign with the bottom number. Just put it out in front of the whole fraction like that. I guess it's technically not wrong if you put it on the denominator. It's just kind of weird. All right. And kind of awkward. So, all right. Any questions about that? Let's see. All right. Okay, I'll go ahead and do number 6. 1/4 divided by 3. So 3 is the same thing as 3 over 1. So I'm going to turn this into 1/4 multiplied by 1/3. And there's nothing we can reduce, so we just multiply straight across. So that equals 1/12. All right. All right. I guess I'll go ahead and do number 7. 5/12 of 48. So of always means multiply or times. All right. So basically I'm going to do 5/12 times 48. And 48 is the same thing as 48 over 1. And then 12 goes into 48 4 times. And then 5 times 4 is 20. And it would be like 20 over 1, which is just the same thing as 20. 20 would be the answer for that. All right. And then let's do a few examples here where we have some variables in the mix. All right, which we know we're going to be doing some algebra, so we're going to be dealing with variables. Actually, it's easier because you see these x's, you can just cancel them out. Done, you know, that's easy. And then we can do 5 goes into 10 2 times. So basically all we have left is we have a 2 on the top and we have y on the bottom. So 2 over y would be the answer. Number 9 is dividing. So first, I'm going to flip the second fraction and multiply. Also, when I have m squared and k squared, I think for right now, I'm just going to write those out like m squared is the same thing as m times m, right? So m times p over k multiplied by 3 times k over m. And then we can just cancel out a bunch of stuff. Like an m cancels out there and a k cancels out there. So on the numerator, we have 3m, p, and k. Doesn't really matter the order of the letters. And on the denominator, everything canceled out. So just nothing, so you just don't need to put a denominator then. So 3m, p, k would be the answer. Number 10 says how many 1/3 cup servings of almonds are in a 5-cup bag. So you would just do 5 divided by 1/3. So you could say that's 5 over 1, like 5 over 1 multiplied by 3 over 1. That's just basically 5 times 3, which is 15. So that would be 15. All right. So next we're going to look at adding and subtracting. All right. So when you do adding and subtracting, it's a little bit maybe more difficult because you have to do, you have to have a common denominator first before you can add or subtract. So if you have the common denominator, then it's really easy. So 9 over 17 plus 2 over 17, you're just going to add the numerator and keep that common denominator. So 9 plus 2 is 11. So you have 11 over 17. And then 3/8 minus 7/8. So you have the common denominator, which is 8. So that's going to stay the same. And then you just need to do 3 minus 7, which we know is -4. And then don't forget that you also have to reduce. So 4 goes into 4 1 time and 4 goes into 8 2 times. So that makes the answer -1/2. Okay. All right, and then the fun part really is where you have different denominators and you have to find the least common denominator. All right, so for 4 and 6, the least common denominator would be 12, right? And there's a couple different ways that you can figure out the least common denominator. And these methods like actually come in handy when you're later on. Like I said, we're going to be doing it with a bunch of x's and stuff like that, so it'll be a little bit more complicated. But like one way that you can help figure out the common denominator is by looking at like the factors of the denominators. So like 4, like if I just did this little bitty factor tree, 4 is 2 times 2, and 6 is 2 times 3, right? So when you're figuring out your least common denominator, you have to have at least 2 2's, because this has 2 2's. And you have to have 1 3 because this has 1 3. So then you know that your LCD is equal to 2 times 2 times 3, which gives you 12. So that's your LCD. So then you just need to figure out a way to write each one of your fractions where your denominator is 12. So then you just have to ask yourself, okay, well, what do I have to multiply with 4 to get 12? And we know that's going to be 3. So that means we also have to multiply that numerator times 3. So that makes that 9 over 12. And then what do we have to multiply with 6 to equal 12? That would be 2. So we have to multiply the top and the bottom by 2. That gives us 2 over 12. So now we can add them together and get our final answer is 11 over 12. Okay. All right. Okay. So number 4, let's figure out the LCD between 10 and 8. So if I use that same method, 10 is like 2 times 5. And then if I did a little factor tree for 8, I would do 2 and 4, and then 2 and 2. So I've got 3 2's right here. So I know with my LCD, I have to have like 3 2's. So 2 times 2 times 2. And then I also have to have a 5. All right, so that gives me my LCD right there. So that equals out to be 40. All right, so now let's just make sure we rewrite both of these with a denominator of 40. So what do we have to multiply with 10 to get 40? It would be 4. So 7 times 4 is 28. And then what do we have to multiply with 8 to equal 40? That would be 5. And then 5 times 5 is 25. So then we just have to do 28 minus 25, which equals 3. So 3 over 40 is the answer. Okay. All right. Let's do something on learning catalytics. Here you go. All right. So we're doing one on learning catalytics right now, which is 2/3 plus 1/4. So go ahead and work on that. All right. Anybody else want to enter your answer? Okay, so it looks like you guys are struggling with this one a little bit more. Oh, okay, there you go. Somebody did enter a correct answer. All right. Okay, so first thing we want to do is figure out the LCD. So the LCD, and really like in this case, 3 and 4 don't have any common factors. So you can just say that, 3 times 4 is 12. So therefore that's going to be the LCD. So 12 is our LCD. All right. So then we just going to ask ourselves, okay, well, what do I have to multiply with 3 to equal 12? And that is 4. And so then you also have to multiply the same thing times the numerator. So 4 times 2 is 8. And then what do we have to multiply with 4 to get 12? So that's going to be 3. And then we also have to multiply 1 times 3 as well. And then 1 times 3 is 3. And then just add 8 plus 3 is 11. So 11 over 12 is the correct answer.
So I accidentally got 9 on the 9, like on the first numerator. For some reason, I just got 9. And so that's why I reduced from to 1 because I got 12 over
okay.
12.
Mm-hmm,
I don't know.
Mm-hmm. Yeah. So yeah, you just had a little boo-boo there. Yeah. It happens.
I thought we were solving it on here. I forgot that we were doing it on Pearson. So I was waiting for y'all to be done, and then I hadn't put mine in yet. That's what took me a while.
Okay. Yeah. All right. That's all good. Thanks for letting me know what's up. Okay, let's see here. So let's do another one on the learning catalytics. Do another one. This one is 2/3 plus 2/15. 2/3 plus 2 over 15. All right, that's on learning catalytics. So go ahead and work that one. So even if you're watching this video later on, you can take this time to try that problem on your own and see how you do. All right. Okay. All right, so first we are going to figure out the LCD. So basically 3 goes into 15. So 15 is going to be our LCD. All right. And then what do we need to multiply with 3 to get 15? So that would be 5. And then we also need to multiply that 5 times the numerator as well. So 5 times 2 is 10. And then for 2 over 15, you already have the LCD there, so you don't need to multiply it by anything. So you can just put the 2 there. Okay. And then, okay, so then 10 plus 2 is 12. So that gives me 12 over 15. Okay. And then I need to reduce that. So 3 goes into 12 4 times, and 3 goes into 15. Oh, wait. Yeah, 5 times. So 4 over 5 is the correct answer. Okay. So, all right, so I can see by the answers that y'all got. So one of you used 45 as the LCD because 3 times 15 is 45. And there's nothing necessarily wrong with that. So if you did use 45, then you multiplied, you know, okay, so that you have to multiply 15 times 2, which would be 30. And then you would have to multiply 3 times 2, which would be 6. And then you got 36 over 45. Okay, but then you just have to reduce that. So then you have to know that 9 goes into 36 4 times, and 9 goes into 45 5 times. Okay, so you can still do it that way and get the correct answer. Just always check at the end to see if you can reduce your answer. All right. All right. Any questions or comments about that? Okay, I'm going to show you another method that I like to use for adding and subtracting fractions. And it's kind of a shortcut. And it's, I call it the bow tie method. And so basically what it is you cross multiply and you add those two products together on the numerator, and then you multiply across the bottom to get the denominator. So, so this would be another thing that you can do instead of using the LCD. So you can use this method for any adding and subtracting of fractions, but I think it works the best whenever your denominators don't have any common factors. So if you use this whenever your denominators do have common factors, then that makes it kind of similar to that last one that we did, you know, where you're just going to have to do more reducing at the end. So it's up to you, like whichever method that you like. But I really like this one, especially when the denominators don't have any common factors. So this is what it will look like. So 1 times 6 is 6. And then 5 times 7 is 35. So I've got 6 plus 35 for my numerator. And then on the denominator, you're going to just multiply across the bottom. 5 times 6 is 30. So then 6 plus 35 would equal 41. So 41 over 30 would be your final answer in that case. All right. Any questions about that? Okay, here's another example. negatives always are like a source of problems for people, right? So if you have a subtraction like this, a lot of people like to do it this way and like make that a plus and then put the negative here with the 5. I think that kind of makes it easier. And so then let's do the bow tie. So 2 times 12 is 24. And I could say plus, but that's going to be a negative. So I'm just going to say minus 35. And that's my numerator. And then on the denominator, 7 times 12 is 84. So then I just need to do 24 minus 35. So that's going to be negative 11 over 84. So negative 11 over 84 is the final answer. All right. So on number 7, in this case, these two denominators do have a common factor of 3. So you can still use the bow tie method if you wanted to, but you're going to end up having more like reducing that you have to do if you do it that way. So personally, I'd probably choose to do the LCD method instead. If I do that, then I've got here, this is like 2 times 3, and this is 3 times 3. So for my LCD, then I'm going to have a 2, and then I'm going to have 2 3s. Like whichever one has the most 3s, that's how many 3s go in your LCD. My LCD is 2 times 3 times 3, which is 18. So 18 is my LCD then. So what do I have to multiply with 6 to equal 18? That's 3. So 5 times 3 is 15. And then what do I have to multiply with 9 to get 18? That's going to be 2. So then that's going to be 20 over 18. And then 15 plus 20 is 35. So it would give me 35 over 18. And then can we reduce that? No, we can't. So that's it. All right. Okay. And I try to wrap this up by 4:30, but let me just do like at least one more example. I want to get in an example that has some letters in it. So number 8, I have 8 over CD plus 9 over D. And we know that CD is basically the same thing as saying C times D, right? So in this case, my LCD, it has to include all the factors of both denominators. So in this case, my LCD is CD. And then that already takes care of this other D over here. Okay. And so then in that case, so the first fraction already has the correct denominator, so that just stays the same. And then I ask myself, what would I have to multiply with D to equal CD? Well, that would be C. CD, same thing as D times C or C times D. Either way, it's the same thing. So then that's going to be 9C on the numerator. So I've got 8 over CD plus 9C over CD. So the denominator stays the same. And then these are not like terms, so I can't really do anything other than just write down 8 plus 9C. So that's the answer. 8 plus 9C all over CD.
I have
All
a
right.
question.
Yes.
Could you cancel out the C's?
You mean like at the end?
Yes.
Okay, thank you for asking that question. That's a great question. A lot of people have that question, I think. And the answer is no, you can't. And the reason is because you've got basically because of this plus right here. So you've got these two terms on the numerator, and both of those terms have to be divided by CD. So because there's like a plus here and that's two different terms, you cannot cancel out those C.
Oh, okay. I understand what you're saying now, because then by that chance we could add 9 and 8 and they're still different. So okay.
Right. Yes. Very good.
Will you stop photobombing? I'm sorry. He's such an attention grabber.
Okay. All right. All right. And yeah, my family was being so incredibly loud. Hopefully y'all didn't hear it too bad, but my dad was literally like screaming with rock music, and then my brother, I think, was playing with my kids, like being super loud. So I come over here so they can watch my kids while I do this.
3 dogs in my room right now. One's just old and sleeps all the time, and then this one, he just cannot go without too much attention for too long. Like he's still a baby. And then my other one likes to have panic attacks in the corner.
Oh dear. Wow. He's all over the place. Okay. Well, so we basically covered all lesson 2. So that's good. Let's see. Anybody have any questions? If there's anybody, let's see. All right. I think everybody that's left. Okay, you guys are good, right? You guys are on my math lab and did your homework and stuff. So, all righty. Just email me if you have any questions. And then I'll see y'all hopefully back here on Tuesday. So I'm planning to do this every Tuesday and Thursday at 3:30. So,
and yeah, like I said, you can use the same link every time. So,
okay.
All right. So thank you so much for participating again today. And I'll see you guys.
Say bye.
Bye.
Bye.